Okay, so in the last video we pared down our factor analysis and we're left with basically 4 factors, and each had variables. Each one, here's the first one, had 5 questions related to factor 1, 6, 7 questions related to factor 2, 5 to 3, and 3 to 4. And this is our factor, rotated factor matrix. These are the correlations of each question to the factor. We also ran it again and got a scoring coefficients. And so for our questions, our z-scores, we have this scoring matrix. So let's copy that. Let's go to Excel to where we have our descriptive statistics with means and standard deviations, and let's paste this. Now we want to sort these so that they are in order that we can line up their questions up here. Notice I have already deleted the questions that are not included in our analysis. So for example, we go to question 1, 3, 5. We're at 1, 3, 5. And so there are some questions that have not been included. So what we're going to do is, right now, our objective is to score all the questions for all the subjects. Right now we have scores. We have factor scores for the first years. These are our first years. But unfortunately, we don't have any factor scores for anybody else, which is not good. We have to get factor scores for everybody. And not only that, we have to get factor scores for each of the factors. So, for example, here are all our z-scores, and here are the 4 factor scores. So we don't have z-scores and we don't have factor scores. Now, what we have to do is multiply each. So we only have 4 factors, and you saw that some were loaded and others weren't, but we still multiply each of these values for each of the factors. So we have weightings on all 28, even though some of them are kind of trivial. It's not good form to just use the ones that were loaded. You go ahead and do all of them in order to get at that variance that we were shooting for. But you have to multiply them against the z-score. So this turns out to be kind of a complicated formula. We can go to what I did on the original BIVS analysis. Let's go to the syntax. I have a saved syntax somewhere. And we can see that we had, in the original study, we had 8 factors. Here's 1, 2, so there's S2s right there. So we have S, it's an S, but really we're going to do F for factor 1, question 1, equals, this was the scoring coefficient, 0.014, times the question 1 minus the mean, that quantity, divided by the standard deviation. So this is a z-score, Q1 minus the mean of Q1, divided by the standard deviation of Q1. And all that is multiplied times the score coefficient. That gives us a score for question 1. We're going to do that for everybody, and then and then for all the questions, and then we compute the factor by summing all those questions. It's a bit of a tedious task. But one of the things is we could go up to transform compute variable and do this for every single one of these. That would be kind of painful. We could type it in, like right here, and do the computing and type in, and we have our means and standard deviations. We can type those in and just do it longhand, but that would be kind of painful. What we're going to try and do, or I'm going to show you how to do, is a shortcut. It's not short, it's a shortcut. And so what we want to do is go to Excel and create these lines and take advantage of the cells in Excel to facilitate this. We could probably do it in Word too, but the thing is that I think it's easier because of the columns. It's easier to do it in Excel. So let's do that. So we come to Excel. We have copied in our factor scores. So let's insert a couple. I don't know exactly how many we need. And so what we want to do is we want to have this compute. This is all text. So this is text. We're going to copy this. We're going to go to Excel. At this point, we're going to cheat and skip a few steps. It was pretty complicated and time-consuming to put this together. So I thought I would just show you the end result, and you can work backwards from here should you ever have the opportunity to do this. We're going to compute the first factor in one step. Each one of these lines represents a question, and then we sum all the answers to get the total factor score. So we have our scoring coefficient from the factor matrix. So we see we have minus 0.015, and that's minus 0.015. Then for that we're going to subtract that from the, or we're going to multiply that times the z-score. And the z-score is a question, the actual raw data question for a particular subject, minus, there's a minus, let's see, so it's the coefficient times Q1, the quantity Q1 minus the mean, which was the mean of question number 1, that quantity divided by the standard deviation. So x minus mean of x divided by SD is the z-score. So this is a z-score, and we use the first-year optometry students as kind of the base, and then everybody else goes from there. So we don't neutralize and center everything around 0. We center it around the means, the 0 of the optometry students. And then we add the third question, the weighted value of the score coefficient times that, and so forth. And each line is that way. Now we use Excel because we can just copy the information from the descriptive statistics and paste it over here. Copy the information from the factor analysis, paste it there. And then we insert spaces and put in the text that's between them. Now we have this, basically these sentences we can paste into the syntax of SPSS. So we have the sum, and then notice that there's a parenthesis that encompasses this first line, plus the parenthesis that encompasses the next question, and so forth down to the bottom. We end with the closing parenthesis that matches this first sum, and there's also a period at the end there. So we have computed factor 1, computes the statement in the transform statement for executing. We do the same thing with F2. Now we go to the second factor. So the weight 0.062 matches that, 0.01, 0.01, and so forth. But the means and standard deviations are the same. So we have 0.067, or they're not. Why is that different? Okay, my bad. I copied the factors. So that's 062, 062, 001. Really, I needed to copy the mean here. The means are the same. So let's do that real quick. So we still have the same mean and standard deviation. Notice 857 up here. 857, 857, 857, 857. So we have the z-scores for each question. The means and standard deviations are the same across all the factors. It's just the factor weights that change. All right, now we're going to copy this whole thing. Make sure we get all the columns. I'm going to copy that. And we're going to go to our syntax. And we're going to replace what's in there, because that is wrong. We're going to add an execute command so that it copies everything. So we've done factor 1 through 4. Let's look at our database. Let's come over here. We have factor 1 through 4. Let's get rid of those. Let's come back to syntax. And let's run all. And now let's put them back in. Now we have some missing data. We did not adjust for the missing data in the TBI. So we actually lost some TBI patients, and we probably should go back and fill that in, although it would be just making up data essentially. So we have a lot of subjects, so it's not really crucial, but it probably wouldn't be a bad idea to do some kind of a neutral number adding in there. But here you see we have successfully computed the factor scores for everyone. And it's a little bit of a pain to do this, but now we have reduced 28 questions to 4 factors. And we don't use all the questions. We should probably go back and look at those questions that didn't correlate with anybody and see if they are significantly different on the groups. See if there's any variance we could account for by those questions. But these are the main ones. And so what you want to do is take a look at the meanings. Now, I've put in over here the factor, and this is the question. And so if we notice I've made a blank line in there so that when we sort, we don't mess up our commands and stuff. So now we can sort by factor and question. And so we see that for factor 1, you can look at those and see now you're allowed, because we've done a principal factor analysis, to try and stick a name to some of these. Doesn't always work, but you might be able to see the commonality between these things. I'm not sure how dry eye relates to poor handwriting, but in any event, that's what it came out as. And there's 4, distant vision, blurred, and then we can, once we've done that, we can do our analysis. In fact, let's, can't do that. Okay, let's look and do an analysis. Actually, I've already done that. Actually, I haven't done it with it correctly. Let's analyze, compare means, one-way ANOVA. We're going to do it by group and our 4 factors. Look at the LSD options, descriptives. This isn't a mixed model because there's no repeated measures. And we see everybody's significant in the ANOVA. But now we have our TBIs, our third years, and our first years. And these are the comparisons, and this is for factor 1. We can look in all the other factors and see which ones are different. Third years and first years differ on factor 2. You can see throughout this that every factor is different with respect to the TBI patients. Let's take a look at what this looks like in a box plot. And actually, let's go to Graphs, Legacy, Box, Cluster. Category is Group. So factor 2, factor 2 is green. So the these are TBI patients, and then these are third years, and these are first years. We look at the green, which is factor 2. That was the one that was significantly different. You can see that it's a little below there, and that's a little below there. So we can get it. The first and third years are pretty close, except for this factor, the TBI, the fourth factor. TBI patients are pretty different on the first 3 factors from the optometry students. And there may be some discrimination between third and first. Third years took the survey, the BIVs, a week before their board exams, and first years took it when they first started school. So the third years were under a little bit more vision stress than the first years. All right, so that is factor analysis and how to reduce the dimensionality of a questionnaire into some perhaps more manageable numbers of underlying dimensions that are involved.